Welcome everybody to the March 15th, 2021 uh, general meeting of Rose City astronomers. This business portion is going to be very, very short. There isn't a lot of news, uh, but we have our basics as usual. Our membership, once again, is maintaining pretty steadily. Our last membership report said that we had 697 members, and this is what we had last year and the year before. So once again, we're maintaining our membership and pretty well. There's a telescope workshop coming up on March 27th. That's done online, but those have been very successful and well attended. The Astro Imaging SIG is meeting on the first Tuesday of the month as usual, Tuesday, April 6th. Thursday dinner and Friday lunch with RCA are happening every week. And now these things, the telescope workshop, the Astro Imaging SIG, and the dinner and lunch, the links are sent to you. So as a member, you should be getting them just in your regular mail. If you want to make sure that you get on, you can contact the telescope workshop or the Astro Imaging SIG people to make sure that you're on their contact list. Our next meeting is Monday, April 19th. Okay, uh, I got 2 requests in the last month for articles. So the first one is a call from Oregon Star Party, OSP. Lars Hedbor contacted me and asked me to promote that OSP is looking for programs or articles, observing programs or articles for this year's OSP printed handbook. His deadline is June 1st. The topic is some kind of observational astronomy. So things like objects in Cassiopeia or double stars or looking for really difficult planetary nebula or some kind of observing technique, something that you think would be fun uh, for other people to use as an observing program. You can write up the article, make the list, and submit it to Lars. Unfortunately, he didn't tell me who to send it to, even though obviously it goes to Lars, but he didn't give me contact information. You can get him on the RCA forum, and you go to the membership section, and it's alphabetical by first name. So you just run down to the Lars and find him, and you can send him a personal message. If that doesn't work, contact me, and I'll make sure that your message gets to him. This is just about exactly 1 year ago, in February, actually, of 2020, I met this man, Ashirwad Tilu, who is a friend of Bhavesh, and he's a member of an astronomy club in Mumbai, India, called Kagal Mandal. And he sent me an email and said that they are looking for articles for their newsletter on astro imaging and asked if any of our imagers would like to submit an article for their next newsletter. I think there's a broad range of topics you could write on. I can assure you, India is full of engineers and scientists. So you can make it about as technical as you want to. I'm kind of hoping somebody will write an article and then somebody in India will read it and they'll become great imaging buddies. Um, let me see. If you, this PowerPoint will be on our website. So all of these links will be live. But if you kind of forget that, just send me a message or Bhavesh a message and say that you would like the contact information. I'll make sure that they get it. Um, we were talking about the theft from Carlton Observatory. Carlton Observatory doesn't actually really exist right now. It's a project of Forrest Babcock and Janet Zwelke. They've been at this for now about 2 or 3 years, trying to do the fundraising. They've got an architectural plan for this, and it would be out in Carlton, Oregon. They had a trailer, and in it was Forrest Babcock's gorgeous telescope right here, this 15-inch, amazing telescope. He said he spent 43 years of his life building that. Here's the trailer that was stolen. I've been seeing a lot of publicity about this. I've seen it on television. I got a Washington County Sheriff's media announcement. I've seen it on Facebook. And I also saw that Janet Zwelke was saying on the KGW news interview that she just wants it back. They just want it back. No questions asked. And they think that somebody just wanted the trailer and didn't know what was in it. There's also a smaller telescope in there, a little Unitron, which is a vintage scope. And that, as I said in the forum, there's been some discussion on our forum about this. That's small enough that it could make its way onto the observing field and maybe nobody would notice right away. So kind of keep your eyes peeled for this vintage Unitron. It's white, it's about that long. Maybe we should try to get an image of something like that and put it on our website so people will know what to look for. If you see anything or hear anything, there's contact information. This is the Washington County Sheriff's Office. There's their telephone number and the case number. And that's all I have for this month.
So, and as usual, Margaret's slides will be posted on the website,
Right,
on the club website. So if you need any of those phone numbers, or if you want to
right.
just review any of the things she said, then you can grab a copy of the slides later.
Okay, I'm done.
Great. Thanks, Margaret.
Mhm.
So now we'll hear our monthly Sky Report from Jim. Hello, Jim.
Hello, and welcome to March. Can you believe it? 1 year ago that we were just talking about COVID and shutting down, and here we are. We made it through a whole year. But welcome to the Sky Report for the month of March. Lots of interesting things that happened since the last meeting. There's been a galore of wonderful pictures taken by Perseverance in high definition. I mean, there's definitely a high definition mission. Lots of cool things on there, some audio, some pictures. There's too much to show, but I encourage you to look at the website. And they got panoramas, they got 360-degree view, so on. They're really kicking on this far as technology goes for this. It's a wonderful tool. Right? And then just recently they used what's called the SuperCam. And that's just pretty awesome that even though Perseverance is parked and they can zoom in on an object with the camera. And so they can get really nice details like this and finding some really interesting close-up shots. And you notice that the names now are Navajo, and they're naming it after some of these rocks and such in honor of the Navajo tribe. And so I think that's pretty awesome that they're doing that. Right. So check out the website and you can see wonderful pictures, and it's just only the beginning. For the month of March, there's an expression that's used for the nighttime sky, in like a lion and out like a lamb. And so what that means is that the constellation Aries the Ram is now in the western part of the sky, starting to set. And in like a lion, it's Leo the lion that's emerging from the eastern night sky before midnight. A lot of times you hear it for weather, meaning that out like a lamb is weather-related winter, and in like a lion, the spring is arriving. That wouldn't be the case in Denver, Colorado right now. Then we have, for the month of March, we had the full moon. Full moon is on the 28th this month. And so we have also an interesting event that happened on March 4th. We had the SN-10 Starship did another test launch. Looks pretty good for a while, for 8 minutes, but I don't know how anybody's going to ride that ship. It's really pretty unorthodox, I say. But then, as soon as it landed, looked like it was just a successful launch and landing. And look what happened. Several minutes later, it exploded. Okay? And so, you know, what did Elon Musk think of it? Well, first he said it landed in one piece. He was celebrating, and then he tried to explain what happened as far as the result from the landing. So now they're even working on SN11. Apparently, I guess it's on the pad right now for the next test. And then look at this shot. This was an astronomy picture of the day, Mount Etna. A beautiful picture with the star field above it. And then they even got a view from space. And so you could actually see the lava flow from space. So it's a beautiful shot on the volcano. Right? And then there was a meteor event, pretty little exciting little event that happened. They call it nighttime. So you could see a lot of blue in this. But around 6 p.m. or so, and a lot of people noticed this particular fireball over Vermont, and had equivalent of 444 pounds of TNT. So a lot of people noticed this, and they got a lot of details on it. One report I saw that somebody found the meteorite. I'm not sure about that, but a lot of reports there. And then we've been talking about perseverance and what have you. And yesterday was Pie Day, so hopefully you had to go out and have a nice slice of piece of pie. And one of the things they pointed out that NASA actually used pie to generate this parachute, right? The circumference and all of that, the design, but hidden within that parachute is the message that use a binary code, and it said, "They're mighty things." Right? And so that was a kind of a fun pointer that they used yesterday to point out Pi Day and to refer back to how NASA engineer uses math to design the parachute for perseverance. Pretty clever. Curiosity had the wheel that had Morse code and JPL, and then they came out with this. So pretty clever group of engineers. So looking ahead, okay? Still evening planet, still kind of hanging out with Mars and Uranus. Morning, yeah, we're getting Jupiter starting to emerge and so on, but definitely winter is not for much observing for planets. Okay? And then on the 22nd, we have a nice viewing of Mars and Aldebaran. And Aldebaran is a red giant star. Last week, Mars was just right next to the Pleiades, really close. It was a nice view with the cluster. And then we're coming up to the equinox, finally getting to that point. And what's happening on March 20th at 2:37 a.m. We're halfway there toward the summer solstice. In case you haven't noticed, the days are getting longer and the nights are getting shorter. What's happening on that day, both the North and South Pole are equal distance to the sun, and that the sun will be directly over the Earth's equator. Right? And so on that day, right, the sun will be about 45 degrees above the southern horizon. That's our latitude. And so that means that we're 45 degrees from the equator. Okay? And so on that day, we'll start seeing the sun going to get higher and higher until it reaches the summer solstice in June, when it'll be 68.5 degrees. Okay? And so here is a nice picture from astronomy picture of the day that shows the position of the sunrise, sunset. And so this is a nice progression to show the difference between the solstice and the equinox. And actually you can draw a line. There's the equinox there. You can draw a line right through the middle and can show where that point with the equinox and then go to the summer solstice and back to the winter solstice. This is a really nice display. If you want to explain about the length of day and length of night, is to have the progression of the equinox and the solstice. Okay. So technically, the 12-hour day, 12-hour night, because of our latitude and the angle from the sun, will be on March 17th. Okay. So 3 days prior to the actual equinox, when the sun is directly over the equator. But for us, for 45 degrees north, the 12-hour day, 12-hour nights, is going to be on March 17th, technically. And somebody will always argue that point, saying, "No, that's not really true." Well, you can point this out. That would be the problem solved. And also, this is also a good time to line up your the sundial. Okay, so you can line it up where the sunrise will be directly east, and then sunset will be directly west. So you can align your sundial nicely on that day, and then you're set. for the rest of the year. And then at that point too, is that's when the ecliptic and the equator is actually intersecting. And that again, the path of the sun is directly over the Earth's equator. And the fun thing too, down in Mexico, at the Aztec temple, and people go there just to get this particular view. On the Aztec is this long snake that it's created by the shadows, right? And down at the bottom, it's the snake's or dragon's head. They call it the snake. Down at the bottom, but this is the time when they see that shadow effect on the temple. Right? And then, of course, the tulips are coming up, and it's the sure sign of spring. So a year ago, a lot of the tulip fields were closed because of the COVID, and they're very happy to be open this time around. And it's also March, it's the time for the Messier Marathon. And so technically, when you go nationwide, many are doing a marathon, and it's on either March 12th to 13th, 13th to 14th, or it's upcoming 19th and 20th. And that's when you try to get at least 110 Messier objects in one night. Okay? It's kind of a fun thing to do. I tried it once. Okay, but if you have to do it manually or go to, depends. But it's a lot of fun. I got too cold, and I just could not make it through the night. March, after all. Okay? But on the YouTube, you can actually go to the Lowell Observatory on March 20th, starting at 6:45 p.m. They're going to be hosting an all-night virtual star party, and they're going to go through the Messier Marathon. That's pretty ambitious, I think, to be able to put that on YouTube. So that would be a fun event. If you've ever wanted to do it, and if it's cloudy and raining here in Oregon, go to Lowell Observatory, and you get to observing. And for the object of the month, I chose the M41. It's called the Little Beehive Cluster. It's a cute little thing. Nice little group of clusters. It's over there by the star Sirius in Canis Major. You can go to Sirius and just drop right down. Down a magnitude of about +4. So it looks good in an 8-inch telescope, maybe even a 6-inch telescope. You can easily find Sirius, the brightest star in the night sky. It's a good reference. Drop down, you see this nice little cluster. And it's at a distance of roughly about 2,300 light years away. This is a nice little one, the try for the winter sky. As far as the sun cycle, we've been pretty active actually. We're seeing more and more sunspots if we move from cycle 24 to cycle 25. And so we have a few sunspots right now on the surface of the sun, and we're creating some activities there. We can see that there's definitely more activities appearing on the sun. And just recently, we just had a kind of a scourge where we had a flare and it created some wonderful northern lights. Not here in Oregon, but it's been pretty wet here. So there's some opportunities that are going to come up, and we're going to have some northern lights, which is actually now at the time from February to May, that this is a good time to start viewing for the northern lights, especially in the northern hemisphere. And then as far as the space station goes, it's visible now until April 6th. You go to the website. It's in the evening, by the way. And there are a few that are really going to be directly overhead. It's a lot of fun. If you've never seen the space station, go to spotthestation.com. Go to any city, look up the location. It'll show you time and what have you. It generally lasts for about 6 minutes, moving from east to west at 12,500 miles per hour. And then, because you're watching the dragon that's still attached to the space station. And just today, they just dropped a great big battery pack from the space station. They were fixing up the solar panel in this huge 2-ton battery pack. They just let it go. And so I'm sure we'll hear about it in the next 2 or 4 years. For April, we got the worm moon. The full moon is on April 26th. Apparently, this is going to be the first supermoon for 2021. And so here are a few things that to look forward to in the month of March and April. encourage you to get some pictures and gather your pictures for the RCA calendar for 2022. That is it. And so we'll see you in April.
Thanks a lot, Jim. So will the supermoon be as big as the full Mars?
I didn't.
Well, thanks again. That was enlightening as always.
Thanks, Mark.
Our speaker tonight is Mel Bartels. Mel is an expert observer and telescope maker. But unlike many amateur telescope makers, he grinds his own mirrors and creates very fast, high étendue, richest field telescopes that have optics that match the user's vision extremely well and allow the user to comfortably view with feet flat on the ground throughout the range of viewing angles. Aside from this achievement, Mel has pioneered other telescope designs and an open source telescope control system. He provides a wealth of telescope making knowledge via his website. You might also know him from his famous telescope walkabouts at the Oregon Star Party, from his articles in astronomy magazines, or from his mirror making classes. He has a remarkable set of accomplishments that I have only been able to touch upon, and I encourage you to read the more detailed information in my announcements for his talk or on his website. We're very fortunate to have him in our local astronomical community. Please give a warm welcome to Mel Bartels.
Hi, everyone. Mel Bartels here. I'm sharing my screen. Is the PowerPoint showing up?
So we're not seeing it yet, Mel?
So when I click on share screen, nothing seems to happen.
So there's an up
I'll
arrow.
switch over.
Okay, there you go. Now it's saying that you've started to share. There you go. There you are. You got it.
Okay, great. All right. So Mel Bartels here. My presentation is The Clouds of Andromeda. I really appreciate the chance to talk to the Portland Club, a group of people that I admire a lot. I think you should all be proud of what you do in Portland, not to mention the world-class Oregon Star Party. So I had a lot of fun putting together this presentation, and I hope you enjoy it too. Okay. So the Clouds of Andromeda. Oh, you can see me there. Adjust my screen a little bit. There we go. I'm holding my 6-inch scope, and then down below is a 25-inch scope. So my presentation tonight, I'm going to tell the true story of obscure little patch of light in the sky and how it came to be the center of one of our greatest astronomical revolutions, the day that we found the universe. So we know the Great Andromeda Nebula is actually a galaxy of 1 trillion stars, 2.5 million light years away, the nearest grand spiral galaxy to our Milky Way. The Andromeda Galaxy also goes under a number of different names too, Messier 31, M31, NGC 224, and there's a dozen other names there. And I guess I get to say the obligatory comment that everyone seems to say when giving an astronomical presentation, which is that astronomers love to come up with lots of names, and a lot of them are not necessarily that interesting. But one of the names for the Andromeda Galaxy, Hevelius 32, is rather interesting. Hevelius is an astronomer who tried to create a catalog that was far more accurate than any before. But as I'll go through in my talk and mention, when we simplify history down to a single person, we often leave out some of the best stories. Well, one of the best stories about Hevelius is that it was actually his wife who published the catalog. So I'm going to show my sketches and talk a little bit about the Andromeda Galaxy and use my sketches and talk a little bit about some of the latest thinking about how the Andromeda Galaxy and Milky Way began so long ago and how they began set in fate our ultimate destination so far into the future. So the clouds of Andromeda actually have three meanings to me. That's the sketch on the left through my 25-inch scope. And you can see that the galaxy is actually surrounded by interstellar clouds of our galaxy. And we look through that to see the Andromeda galaxy. So that's one meaning for the clouds of Andromeda. Another is that the Persian astronomer, as far as we know, is the first to note the Andromeda galaxy as a little cloud. And I thought about why would it be so obscure? And I think the Milky Way, with all its variations and brightness, a little patch of light off to the side probably didn't get too much notice. And then also for those of us in the Pacific Northwest, in the fall, waiting between the storms for those clear nights when it's dark early and the air has been cleared by the previous rain, another third meaning for the clouds of Andromeda. So one of my all-time favorite objects to show people is that little, what I call the Andromeda shelf, brightening there to the lower right of the Andromeda galaxy. It's just a little bit beyond M110. In particular, you can see that if you shake your scope a bit, that glow begins to pop out at you. Of course, we all focus so much on the galaxy that, at least for me, for many years, I didn't bother to really look around it until my wide field scopes came online. But there's a lot to see when you step back from it. So, and this is a drawing through my 6-inch scope too. And by the way, I tried to orient the sketches tonight so that they're all in the same orientation. So some of them may have wording upside down. So with each telescope that I make, with each mirror that I grind, I come back to Andromeda to observe it again. And each time I see something new. At first it was just a patch of light, then it was finally a dark lane, then two dark lanes. Years ago when I had my 24-inch, I spent nights observing objects in the galaxy itself, individual stars, nebulous regions, clusters. And I thought finally I'd seen all there was to see until that first night with my 6-inch. And I'd aimed it at the Pleiades to begin that night with. And I thought, oh my gosh, there's something so wrong with this telescope. There's this broad, faint glow around the Pleiades. And as I moved the scope around, I realized that the glow was actually in the sky, the Pleiades bubble. And I guess we just forgotten about it for a generation or so. So then that was very exciting. And I thought, well, I'll relax and swap over to the Andromeda galaxy, just have a great view through a rich field scope. And I really surprised myself when I did. I could instantly see that, that this observational question that had occurred over the years, for instance, how big is the Andromeda galaxy? Some people have said 3 degrees, some people say 2, but I could see that there are extensions on either side of the Andromeda galaxy that stretched out to about 5 degrees. But I didn't think these extensions were really part of the Andromeda galaxy. They had a slightly different feel or look or hue to them. So that was really surprising. And here is the extensions. And then down below is the Andromeda shelf. So another thing that I saw too was that the galaxy seemed to be twisted. And I got the best view that I ever had through my little 6-inch scope. I don't know if the drawing really shows a twist very well here, but you can see that the spiral arms have been pulled up. And today we think that Messier 110, this galaxy down here, punched through Andromeda. So by the way, there's a perspective here too. The galaxy is nearly edge on, and so the projection or perspective is that M32 up here appears to be further away, but M32 is actually closer to us, and M110 down here is actually further away from us. So I got to thinking, if the Andromeda galaxy is twisted, maybe the Milky Way is too, and sure enough, a recent article came out saying that the Milky Way is twisted. And I think this would be a great observational program or investigation to see if there's some aspect to this visually or digitally that we could capture, just like with the Andromeda galaxy, maybe some objects or stars, some way that we could look into the sky and see that our Milky Way is twisted also. So some of the interstellar clouds in Andromeda. I've given names to. There's an arch-like cloud over here. Here's the drop off. Down here's the dagger, and here's the what I call the comma. And then M110 and M32 up here. So my first night under the stars as a kid in a Portland backyard. And, you know, it was an experience I still remember. You turn off the porch lights, you go out there in the dark, you set up your scope, and everything just seems to recede. The sounds, the light, and you get your star atlas out and you look at your first objects ever in your lifetime through this telescope. First object I looked at was Mars. And I didn't know at the time that Mars is best seen at the opposition. It was just a little orange dot. Now, some people's reaction might be, oh, this doesn't seem like a lot of fun. But my reaction was, wow, this is going to take a bigger scope. And this is a really tough hobby. I can't wait to get into it. The next object I remember seeing was Alcor and Mizar. And they were such beautiful blue-white stars. I still have that visual memory in my mind. The third object was a Hercules cluster. That was difficult, a couple faint little stars. And then the other object I saw was the Andromeda Galaxy. And here's a sketch of that memory I have from that Portland night. And of course, it isn't much to look at, but I knew as a kid that the Andromeda Galaxy was far away. And so sometimes you supply mental understanding to make an object come alive. Of course, a few years later, there is a Star Trek episode, you might remember in Classic Trek, where the Kevlons, people from, well, aliens from Andromeda, took over the Enterprise and modified it, but it was still going to be 300 years to reach Andromeda. So you know if the Kevlons say it's 300 years to Andromeda Galaxy, it's really far away. But, you know, in Classic Trek, there is no one who knows the bad side of us as much as fellow humans. And so Kirk and his bodies defeated the Kevlons by using the worst of our human characteristics. So maybe there's more truth to that Star Trek than we admit sometimes. So my parents did some good things for me. They bought me a telescope. They bought me a chemistry set, which is why this eyebrow here is still missing a couple of hairs. Funny thing was when I came up to dinner, no one said anything about what happened in the basement, which I thought was interesting. Bought me a microscope. They paid for music lessons. And so I had a little 4-inch telescope, which came from Sears. You might remember Sears with the good, better, or best labels that they gave stuff. But as much as I liked my scope, and I gradually learned how to use the telescope, I still thought, you know, it just has that little 6x30 finder, which was fairly modestly, barely useful. What I really wanted was a Unitron because it had a lot of finders. And I knew scopes were rated by the number of finders that they had. So let's see here. And so here I am with my 25-inch and the full picture of the Andromeda Galaxy. I do recall back then going to the Portland Downtown Library. I thought the people in there were so smart. They were so quiet. They didn't move while they're reading all these books. But I came to see, after I got over my Unitron craze with all the finders, that the value of a telescope is, in my mind, determined by the observations, the images, the data taken. I think a telescope can be beautiful. To me, the value of this telescope is the usability of the scope, which is related to the size and weight. I think the focal length or length of the telescope tends to set the weight and overall size. So I've come to see telescopes more and more as a combination of focal length and aperture and focal ratio, and not just aperture. I think when telescopes first came out, they were rated by their focal length. I think the focal length has extra meaning to me too. All right, so let's a little bit talk about sketching. So sketching is this process where I observe by hand, observe by drawing. It's not that you study the object or you see more. It's this act of seeing the object through the act of sketching. When I look through the eyepiece, I form a thought or a narrative or a view that I then attempt to express through my hand by sketching. What you're seeing tonight is the final product, but it is the experience and process of observing and sketching that creates my view and creates the meaning of the object to me. And then when I return to the object, I start with my memory of the view and the recollection of my entire sketching effort. So I'm going to show you some of the sketches that I've done. So here's a dumbbell nebula, M27. And this object comes across as cold and fiery. You can see that it's erupting at the top and bottom. You can see these faint extensions where it's thrown off gas violently. It just has a perspective to it in my scopes that I'm trying to attempt to capture here with this. So one of my favorite objects is the Cone Nebula. I fell in love with this object because growing up as a kid, the Palomar 200-inch scope had this fabulous photograph that appeared in many of the astronomy books. But the Cone Nebula was so far beyond what I could see with my skills and scopes at the time. I did finally really see it with my 13-inch zip dop over there on the right-hand side. And one night, I just on a lark or whim decided to take my 10-inch scope that you see there and aim it up at M8182. I'd heard of integrated flux nebula. I didn't really expect to see anything, but I was just blown away that there was something there and there was some detail there, and it's actually not that dim. And so, you know, it's a thrilling feeling. You're by yourself in the dark, and you're pretty sure that you've seen something that only a few people on Earth have ever seen, mainly because people just haven't looked that much. And, you know, it's just a wonderful feeling there. So integrated flux nebula, galactic cirrus, dust clouds thrown far above and below the galactic plane. And they glow from reflected light from our Milky Way. Hence the integrated flux name. One of the most beautiful, I think, is this double arch galactic cirrus or integrated flux nebula that comes off of CoCam. This is actually a couple of 3 views of through my 10-inch scope or so. And there are these wonderful wide field objects. This happens to be SH2-308. I imagine there are other names. Like I said, we don't do a very good job with names, but we have lots of them. This is a beautiful object to look at. This is just with the 13-inch scope. The more I observed this, the more I drew it, the more I could see, the more I would return to it. And in the upper left, you can see how it looks on nights of different transparency. So an object like this needs darker skies. Okay. So how do I sketch? Well, I've gradually migrated to doing a lot of studying ahead of time. I don't star hop as much because of my wide field telescopes. What I actually do is I study nearby asterisms, and then I aim in the general area, and I just look to find those asterisms to locate the object. And I began studying the object, and I just jot down a rough series of sketches and notes, usually scratches, a ballpoint pen on paper, really dim light as possible. I'll go over multiple fields of view and make a number of scratches across a number of pieces of paper. I'll build a strong visual memory. It's good for a couple, 3 days. Then the next morning, or maybe later that night, I'll draw a preliminary charcoal sketch. That always raises a series of questions and omissions that I just didn't see the first time through. So then I'll come back to it a second night to answer those questions and confirm the initial drawing. I then create a final charcoal sketch the next day. And then the presentation that you see is I scan the sketch and I adjust the contrast to brightness and invert the drawing. So that's how I sketch. So this is a mosaic of the Veil Nebula, a series of sketches that I stitched together in an imaging program. And what I'm trying to portray here is the ability of sketching to show amazing detail in these wide angle views. And also to get a sense of the Veil Nebula itself, this vast bubble where certain parts of it are illuminated more than others. What I really see here is a little bit like the Demo Nebula, only fierier and more explosive. One of the largest scale objects I've ever observed is this series of galactic cirrus, or IFN, around the handle of the Big Dipper. And you'll notice it's a conglomeration or mosaic of different wide field sketches with several galaxies noted there. And I put it together. So one night I thought, well, maybe I could see this with the unaided eye. I couldn't. Maybe I just need darker skies. But I did go grab some cheap 7x50 binoculars, and you know, I could see most of that arc. I wouldn't have known that it was there unless I had sketched it and drawn it, but it was there in the binoculars, and that just amazed me. It's one of the largest scale objects that I've seen out there. Okay, so one of the things too is color. And I was noticing one night in the 25-inch that the Ring Nebula looked a little bluish green. And then I noticed these flashes of red tinge just on the edges from time to time. I actually don't like the view. Aesthetically, it's kind of an ugly color combination, but the color is definitely there. And other people who've looked through it have been able to see it. Not everyone though, and it's interesting that some can and some can't. I'm not quite sure what the conditions are, and we need to do more observational research on that. But there's occasionally color that can surprise us too. The right-hand side actually shows the Ring Nebula at high power. There's an extended ring, a faint glow around it that you can see. And there's actually an even fainter glow around that I haven't quite managed to observe yet. But the Ring Nebula itself, something that we see all the time, could be quite an interesting object. And here's the moon at high power. The straight wall, I think, is fabulous. It's really bright, but it's a wonderful view. Okay, so what do you need to sketch? Well, that's the minimum. A pencil, a couple of stubs, some charcoal, piece of paper, clipboard, eraser. Not a whole lot to it. So a few years ago, with the Eugene Club, gave a presentation and worked out ahead of time to go buy the materials that you just saw for everyone who's going to come to the meeting. It costs about $4 a person. And we handed the materials out in the planetarium and then turned off the lights. And I said, let's sketch 3 objects: Saturn, M64, and a straight wall. And of course, most of the people protested that they weren't artists and they couldn't do it, but I just asked them to try anyhow. And you know what? It was amazing to see what people did. It didn't matter what their abilities were or what they thought their abilities were. People had really interesting perspectives. Some people emphasized certain aspects of what they saw, but almost everyone came up with something that was really interesting, I thought, to look at. Here's a combined picture of what some of the people offered or volunteered to allow me to take a group picture of. So it turns out, I think, that we can sketch as a way to observe. Okay, so many of you have seen the Andromeda Galaxy telescope, or you've imaged it, or you've seen pictures. What do you think are the seminal defining characteristics? How would you explain what you see? What's your narrative? On the left is Herschel's drawing. There in the middle left is Charles Messier's drawing. Next to that is Etienne Trouvelet's drawing, and then a modern drawing by Jeremy Perez. When you look at that, what strikes you as the most important characteristic? That it's elliptical, or that there's a couple of dark lanes, or there's maybe spiral arms? You know, what do you think you see that you would express? So we'll come back to that because it turns out that that's actually quite important as to how the galaxy became the center of the day we found the universe. Okay, so the size of the universe. So I just really wanted to put a couple of comments here to show you that we've been thinking about that since antiquity. We've largely thought, Aristotle's view, that we lived kind of in a finite, measurable area. However, people from time to time thought maybe it could be otherwise. In particular, Thomas Digges said that stars are scattered throughout a boundless space. And Bruno said that the center of the universe was everywhere. There was no circumference. Isaac Newton himself thought that his gravity would work better in a cosmos without a border because he was afraid with a border, everything would come clumping together and gravity would fail. But over time, most agreed with Aristotle. The horror of a boundless universe was just simply too much to contemplate. In 1750, Thomas Wright said that the Milky Way shows that we're off center. And then Immanuel Kant, a few years later, said that the elliptical nebular patches in the sky were actually universes like the Milky Way. But still, we mainly adhere to this Aristotelian view. Simon Marius, German astronomer. So, did you know that Simon Marius discovered the moons of Jupiter, the Galilean moons that we call the Galilean moons? Galileo and Marius had this huge tiff, and Galileo won, and Marius was consigned to oblivion, even though he co-discovered and named the moons of Jupiter. Well, Simon Marius also provided the first documented view of the Great Nebula through a small telescope that remarkably, when the telescope finally was invented or word of it got out, within weeks or months, everyone in Europe had one. I think it's one of the most marvelous stories about telescopes that up to that point, hardly anyone had one, and then all of a sudden, everyone had one. There was some key breakthrough that made it possible to where everyone would go, oh yeah, that's how you make a scope, and there it was. He described it, the Andromeda galaxy or nebula, as a diluted light of a flame of a candle seen at night through a candle horn. So I'm not sure I've seen too many candle horns, but I can imagine how faint and fuzzy it was in his small little refracting telescope of what, an inch aperture or so. That's Simon Marius. So let's talk the next round, William and Carolyn Herschel. So Herschel, perhaps the greatest observer all time, but you know, when we simplify historical stories down to a single person, we leave so much out. I would say that I consider Carolyn and William the greatest observers or observing team of all time. William said, and when in the course of time I took up astronomy, I determined to accept nothing on faith, but to see with my own eyes everything that others had seen before me. He was a composer. He liked to compose catches. Catches are rounds where the music gradually catches up with each other. And as the words are juxtaposed together, new phrases, a little bit body and meaning would come out. And in fact, the Star Spangled Banner was a catch, not composed by Herschel, that started that way. So his sister Carolyn was one of the great observers of all time. She discovered 8 comets. She was the first woman and the only woman to receive the gold medal from the Royal Astronomical Society until Vera Rubin in 1996. And what she did was she got William interested in viewing. She co-discovered M110 and said, you know, William, what do you think? And he goes, wow, we ought to be looking at this stuff. She organized his data. She made his observations researchable. She co-discovered 2,400 objects. And let's see what else. Yes, okay. So she's also was quite the telescope maker too. And there's a picture of her with William over there, grinding away on a metal mirror. So there was a series of really popular maritime novels in the era that came out called The Meritorious Command. And the hero in these novels, Captain Aubrey, visits famous living scientists of the era. And we get to know these people through these novels. And so here's one of the quotes from one of the novels, and goes on to say, let's see, oh yes. So ask Carolyn to measure an arc whose cosine is not, and she'll reply pi upon 2. It's all there in her head. And goes on to describe how she will work a 6-inch mirror grinding for 3 hours straight without a break. So she was right there with William and made the mirrors. And today, she might very well be a back-end developer, organizing the data and so forth, while William maybe is the front-end web developer. Okay, so size of the universe round 2. So William got involved and really interested because he began to resolve some of these patches in the sky into stars. So he thought, well, it's reasonable that maybe all of them are resolvable, but he couldn't do that. And so the question, since his time, is, do they all resolve into stars? Could some of these patches, elliptical patches, be other Milky Ways? Just didn't know. And so round 2, Lord Ross built 36 72-inch scopes, tried to see if he could resolve them. The spectroscope came about, and this is a really interesting story, because when William Huggins aimed his spectroscope, he instantly saw that the planetary nebula was gas. Oh, well, maybe they're all nebula within our Milky Way then. Oh, but then in 85, a supernova in Messier 31 was so bright it was thought to be a star, and therefore the Andromeda galaxy had to be close, because you couldn't have a star that far away. That didn't make sense. For photographs by Isaac Robert, just astounded the world, but it was a wide hazy cloud. It was a planetary system. And at the turn of the century, 1900, the famous popularizer of astronomy, Agnes Clerk, declared that no competent thinker could ever maintain that a nebula is equal to the Milky Way. Such thoughts were grandiose. Please don't even bother with that. And yet, at the same time, Julius Schneider was spending 7.5 hours obtaining a spectrum of M31 that resembled the light of stars. And then astronomers who ought to be better known today had faith using the Crossley telescope, confirmed the findings. But then George Ritchie, in his photographs, saw that they were smooth mix of nebulous material and soft star-like condensations, no island universes. But then they photographed stars, supernova, nova in these galaxies, and Curtis came to believe that they had to be island universes. And so Slipher found that M31 was moving too fast toward us. And there's a story, I'll tell a little bit about that. The other spiral nebulae were actually moving away from us. These speeds were too great to be part of a Milky Way. They wouldn't stay part of the Milky Way. They would just be flying through us. Something wasn't right. And when he announced these findings at the very first meeting of the American Astronomical Society, he received a standing ovation. So the mystery is really on now as to what is going on. So round 3, Edwin Hubble, he's the one on the left. And Hubble had Hollywood looks. He was smart. He was a Rhodes Scholar. Oh, his maternal grandfather was related to Jesse James. One of his relatives built a telescope, and on Hubble's 8th birthday allowed him to stay up and view the heavens. And that started Edwin Hubble's love affair of astronomy. And he remembered that impression his entire lifetime. He was a whiz at calculus. He was a star on the 1909 National College Basketball Championship team. And whatever you may say about him, good or bad, he put in the hours and he got the results when others didn't believe or passed up the opportunity, like Shapley, leading authority in Cepheid variables. And there's a picture of him at the 100-inch telescope, Newtonian focus, guiding away. So, the day we found the universe. Henry Leavitt, who found the Cepheid relationship, Humanson down there on the lower left, he's quite an interesting story. He was hired as a janitor and then began assisting. And eventually he went right from an elementary school education to obtaining his PhD. And he did a lot of the guiding of the images. Some of the pictures he took were up to 7 nights of guiding, where they would seal up the photo, then open up the plate again the next night. And there's a famous story that when he retired, his son wanted to get him an amateur scope so that he would actually have fun looking through an eyepiece for once in his life instead of just studying and concentrating on these guiding scopes. And he turned to his son and he said, "My God, Bill, I've had it looking through an eyepiece. I never want to look through one again." And he took up fishing instead. And this picture over here on the right, I think is really interesting. See the little N had got crossed out? So Hubble originally thought he had found another nova, which they had already found some, and it would help support the case that the Andromeda galaxy was another galaxy like the Milky Way. But it wouldn't be really breakthrough or conclusive. But then he saw it come back, and that's when he wrote down on the plate that it's a variable. And I don't know if you've had a chance to ever see, by the way, V1, right, for the verse variable. See how much it brightens and dims. I actually don't think that's that much variation, but there it was. And then he knew what the answer was. But it took George Lemaitre theoretical framework for there to be a physical basis or a theory to explain all this. So it leads to one of the great stories in astronomy. So Hubble writes to Shapley and says, "Well, you'd be interested to hear that I found a Cepheid variable in the Andromeda Nebula." And Shapley read the letter. Cecilia Payne, a famous astronomer, was in his office, and he held out the letter to her and said, "I think my universe has just been destroyed." However, he wrote back to Hubble, "Your letter is very entertaining. It's one of the most entertaining pieces of literature I've read in a very long time. It's interesting that you found Cepheids in the direction of Andromeda galaxy, but you know, they're very touchy feast and difficult and faint and so on." But ironically, he would later go on to champion Hubble's conclusion. So this is the day that we found the universe, the day the universe went from our galaxy to uncounted galaxies, the day that has enabled all the other days in astronomy since then. By the way, Hubble thought that the word galaxy was inappropriate. It should be reserved from the Milky Way. And it wasn't until after he died that we began calling the Milky Way galaxy and the Andromeda galaxy as separate names. So it turns out that the Kevlons were onto something in Star Trek. They did know that the galaxies were far apart, and then Hubble went on, and remember, this is just a little less than 100 years ago, to do redshifts along with Slipher and discover that these galaxies were receding faster and faster with increasing distance. And in fact, so much so that Hubble himself became uncomfortable about it, and he would often suggest alternative stories to account for the expanding universe. I mean, if you took this to the extreme, the galaxies would be flying away from each other at faster than the speed of light, and that just couldn't be. In fact, Einstein resisted the idea too, and it took a visit of Einstein to Hubble and Mount Wilson to change Einstein's mind. he got to look through the scope and everything. So yeah, sitting on that iron frame, all that guiding during those cold winter nights, uncomfortable, keeping the guide star centered, the eye strain, the monotony, the constant awareness, the test of endurance, exposures lasting for night after night. It was really something remarkable. And the Andromeda Galaxy, this little patch of light went from this little obscure spot off the Milky Way to the center of all this story. And it enables me and us now to understand some of these really far away little patches of light. This is Andromeda's parachute. It was just discovered not very long ago. It's that little arch right there. You can actually see this in a rather small scope. It has a dot of light. Here I could manage to see it where it's a parachute. If you have larger scope under better seeing, you can actually resolve it into the 3 individual quasar images. This one is 11 billion light years away, almost to the edge of the universe, and is remarkable. But again, like I learned from that first night in that Portland backyard, it's not the brightness or necessarily the beauty of the object, it's what we also know about it that counts too. So you might remember I was just talking about observing all these objects in Andromeda. And at the time it occurred to me, I wonder what the view is that would have the most objects possible. This is from the Hodge Atlas, which I looked in my library. I do not have. I should have bought back when it was, what, 30 bucks or so. I saw a used copy on the internet the other day for 500. So I should have bought it when I had a chance so many years ago. But look at all of those objects, stars and clusters and nebulosity, all in a field of view or maybe in an adjoining field of view. And so what other views are there like that out there? Well, of course, we know the galaxy clusters, but what else? So I propose a new observing project, at least one I'm going to be looking into, richest field object cluster observing. This is looking in the M6, M7 direction. And there's a dozen objects in here of different types that you can see in a single field of view through a small wide field telescope. And I noticed that with my scopes when I first started looking, like, oh, there's 3 globular clusters in there. Oh, there's a couple of open clusters, and then there's some stars and nebulosity there. And that's kind of interesting. Of course, we know about the Virgo cluster. You can see a ton of galaxies. What's interesting about the Virgo cluster is that it's about 60 million light years. So the light that we're seeing today left the Virgo cluster about the time the dinosaurs were enjoying their last walks on Earth. Another famous galaxy cluster is the Coma cluster. If you have a larger scope, you can see dozens up to 50 to maybe 100 galaxies in here in a single field of view. This one's 300 million light years away. When light left that, continents were still merged into a single Pangea, and it was the Paleozoic era. So I got to thinking and preparing this presentation, maybe there are other groupings too. So please don't try to look at all the individual numbers here. This is a query at the Saguaro database, about 10,000, 11,000 objects, field of view, and pretty modest. The objects have to be about 4th magnitude, or I didn't count them. And there are 16 groups of 6 or more, up to 27 objects in a single field of view. So how about tracking all of these down? And that's just in the 4-inch. So around a query for a variety of apertures, 8-inch apertures, I get 33 groupings of objects. So many of them are galaxies, but not all of them are. With larger apertures, I get even larger groupings. So potential for a new observing program that would be really interesting. Variety and contrast of all of these objects. Okay, so I'll conclude then, talking a little bit about what we think the Andromeda Galaxy and Milky Way, how it came about, and what our ultimate fate is. So this has to do with the Council of Giants, 12 galaxies, like in, what was it, Battlestar Galactica, the 12, you know? So up here on the left, we start out with Centaurus A and Matthew 1, two giant ellipticals. And then we see that these spirals, 83 and 64 and 94 and 81, 82, and I see 342 and 253, the Circinus, and NGC 4945 are all kind of in a circle around us. 10 spirals, 2 ellipticals. Now look at the side view. Isn't that remarkable? So we think that all of these galaxies formed out of what we now call the local sheet, a very flat piece of galactic real estate, if you will, almost 50 million light years across and only 1.5 million light years thick. These galaxies, particularly the two ellipticals, blew gas out toward the center, and that's how the Milky Way and Andromeda began. So remember when I said, so what are some of the seminal characteristics? Well, the Andromeda galaxies nearly edge on. The inclination of these galaxies is much more oriented than by chance. So Milky Way, Andromeda, pretty edge on to each other. And we have been set on this path where we are going to merge. But this is the time of year, and also for the next month or two, where you can actually go out and see this Council of Giants all at once in the sky, except for maybe Circinus down here and maybe Centaurus A, but we can see most of them here. And I plotted them out on a Messier object chart here that you can see them. So thinking about all of those surrounding us in a plane and setting us, birthing us and setting us on this path. So what is our path? Well, in 4 to 5 billion years, Andromeda Galaxy and the Milky Way will begin its dance to merge. It'll actually be another 5 billion years before we gradually merge into a giant yellow elliptical galaxy. There was a research paper, this came out a few days ago, that says that once that happens, 10 million light years from now, the two black holes in the center of our galaxies will very rapidly merge together in something like 17 million years. It won't take them long to do that. I just watched a presentation by Pascal Lee, astronomer at SETI, and he provided a very convincing case that the number of intelligent civilizations per galaxy is probably 1, maybe 2 or 3. And so we might be it for the Milky Way. There might be someone Andromeda would be, but it's going to take a lot of billion years for us to get close enough to where we can say hello. And that's quite a sobering thought. So that's my presentation, Clouds of Andromeda. Somewhere something incredible is waiting to be known. So if you have any questions, you can put them into the chat, and perhaps Mark can organize them and repeat them to me.
Sure. So thank you, Mel. That was really, really nice. We did already have one question show up, and someone, David, was wondering if you use an equatorial platform or a drive for your telescopes, or do you track by hand while you're sketching?
I just push by hand. There are times when I miss an equatorial table, but I move the scope around the sky so much, it's not something that I require. But I would like to add tracking, but I don't have that right now, and I've not used it for years.
I was also wondering if there is an atlas that shows some of these integrated flux nebulae.
There is not. So I started a catalog. I have, what, over 100 of them now that I've sketched. This all actually started back with dark nebula, because if you ever looked at the Barnard photographic atlas, dark regions, or in an atlas, they'll just have like a dot there. Or in the photographic atlas, it'll just say, well, that's B84 and that's B86. And like, well, what exactly is it? How do you outline them? How do you know? So I started sketching these dark nebulae just to make it clear in my mind where the boundaries of these dark nebulae were. And so when I started to see that I could see these integrated flux nebula, I decided that, well, I wanted to have a catalog. So when I came back to it, I could see it for myself and also share with others what these look like. So I have over 100 sketches of these areas that I found, and I only covered a fraction of the sky. I would estimate there's 200 to 400 more out there in the Northern Hemisphere, and an unknown number of them. But I try to sketch them to get some sense of what they are. So in terms of the atlas of them, I would point you to my webpage about them and go out and let's compile these objects.
Thanks. So David remarks that some of your sketches show hundreds of stars, and he's wondering if you're using a star chart to set up your sketch or whether you're drawing those from memory too.
No. I'm terrible at what would you call it? Orienting a sketch. I always get the triangles out of balance. So I typically in the final sketch will, if the star positions are critical or important, I'll just start with a piece of paper and I'll hold it up to the window and I'll mark in the important stars that I saw and get them oriented better. Because if I don't do that, then the gaseous nebula that I'm trying to sketch don't come out the way they're supposed to, and it's not what I saw. So I have to do that. Now, in some of the sketches where the precise orientation, location of stars isn't important, I'll just freehand that in, and then it'll be, anyone's guess to see how accurate that is.
Harold noticed that your sketching tools involve black pencil on white paper, but he was noticing that the sketches you've shown are white on black, and he was wondering if you ever digitize them and then just invert the colors.
Right. So I do black charcoal on white paper. I have tried white sketching pencils on black paper. I have those supplies and I'll try it from time to time, but I cannot do that as well as I can with the black charcoal on white. So ironically, Andromeda Galaxy is one of the hardest ones to draw because you get the double dark lanes in there, get very confusing when you're doing it inverted as to what actually is the bright and what actually is the dark. But I do the black on white, and then I scan it, and then I invert and I adjust contrast and brightness to make it look as close as I remember in the eyepiece.
Jim is wondering if you'll be writing a book about your work soon.
No, I'm not a writer. Maybe someone else can.
So there are a few comments here and that you might want to review later, and you can just save a copy of the chat if you want. There might even be one automatically saved for you, Mel, but I'll just hit the questions.
Okay.
So Doug is wondering what the source of the Council of Giants illustrations was.
Yes. Right. So a paper published by Marshall McCall called The Council of Giants from several years ago. And last I looked, that was a free PowerPoint you could grab off the web. The name again is Marshall L. McCall, Council of Giants.
Gary's wondering if you ever start with black paper and draw the light that you see in white pencil or chalk.
I do that from time to time. I can't get it as fine controlled on the fainter grayer areas as I can with black on white. So I try it from time to time. I just can't get it the way I want it to. So most of mine are actually the black charcoal on the white paper.
Howard is wanting to know the source of the estimate that there's one intelligent species per galaxy.
That's a recent talk. So if you would allow me a few seconds diversion. So COVID, right? Really interesting to see how some astronomy clubs have really thrived and others have struggled a bit. One of the clubs that seems to be doing well, like the Portland Club, is the Kalamazoo Astronomical Society. And they recently had Dr. Pascal Lee from the SETI Institute give a really wonderful talk. By the way, he's a well-known painter too. He, illustrated his talk with some of his paintings. And he said, ironically, that in a talk as a member of the SETI Institute, he's going to say something that maybe the Institute naively might not like to hear. That is, there are not many of us out there. But he gave a really well-reasoned talk as to why the number just cannot be very much, even optimistically. And in his mind, you know, in the SETI world, there's something called the barrier. What is it that we go from, like, for instance, we think in our own solar system, there could be up to 10 places where primitive life might exist or might have existed, 10 places in our own solar system alone, but only one Homo sapiens, as the Kevlins found out to their demise. So where is that break? You know, what's so difficult? And in his mind, it's the jump from multicellular life, primitive life, to intelligent civilized life that can do technology. He also pointed out other barriers too. So you probably all, or many of you have heard that our sun has a habitable zone, but our galaxy has a habitable zone too. And it really has to do with the gamma ray bursts, which will destroy life on the surface of planets. We are right on the inside edge of this habitable zone for the galaxy. So when you put all this together, it's pretty hard to come up with, in his presentation, which I found very convincing, a number of n that is, you know, much more than a handful. So, so let me just add. So he suggests that SETI should reorient themselves to look for life in other galaxies. If it's possible and plausible that it's so rare in our galaxy, we need to be concentrating on other galaxies.
So Lorraine said that she would like to know more about the design and construction of your beautiful telescopes.
Well, so I have web pages on that, and I would humbly suggest you look there first, and then you can get a hold of me if you have questions, or come to the Oregon Star Party.
Allison made a kind of a similar comment. She said all of your scopes are wonderful, but she said that it seems like your 6-inch was special. Could you say a bit more about it and its mirror?
Sure. So if you don't mind, I'm going to go backwards up here and get back to the very first slide. So hold on. There we go. So in the upper left, that's the 6-inch. So it's a 6-inch f2.8 mirror, super fast. It gives almost 4.5 degree field of view with the wide angle ethos eyepiece. You need a coma corrector, of course. So what I've come to see is what I regard, at least in my mind, a little bit more sophisticated view that the aperture is just one aspect of it. Focal length is another. The focal length of this scope is only 17 inches, but it's f2.8. So I get this really wide, almost binocular field, but I get it with 6 inches of aperture. So these really faint objects are so much brighter in the 6-inch than they would be in other scopes, although truth be told, other scopes can come quite close to that.
And Gary is wondering if you've ever framed sketches for sale.
I have not. I wouldn't mind that they be out and about, at least for me to look at. And right now they're just all, you know, in a sketchbook.
He feels that a gallery show would be a great fundraiser for RCA or OSP or some other charity.
Well, sure. That's very generous of you to say. If you saw how they started as these horrible ballpoint pen in the dark scratches and a comment about like next to this star, but not quite, in reading and words I can hardly see the next day. That's, now you know why I go back night after night to try to get it better. So.
And he also made the suggestion that it would be really interesting to see your transitional sketches, starting from what you draw at the eyepiece all the way through to the finished sketch, kind of all on the same board, just to see the process.
I thought about that, but they are so embarrassingly bad. I just can't bring myself to do it. So, I would point you to Howard Banich and others. Howard is just a world class beyond me. Ask him to show us the interim stuff. It's going to look a lot better than mine.
Gary also made the suggestion that he was wondering if you've ever given a presentation about your shop where you built the telescopes. And he said the Woodworkers Guild or the Woodworkers of Oregon Guild might be particularly interested.
I have not, but I will say that, who was it? Oh yeah, so one of the groups I participated in. So see, one of the reasons why I do telescopes differently each time is that I'm not a very good telescope builder, and it takes me a couple, 3 times to get it right. And the other thing is okay, so I know it's gonna be kind of weird to hear, but I don't have patience. And why I make these mirrors, I do not know. Ask my wife right now. She's going, why are you making a 30-inch mirror? You don't have the patience for it. I don't know why I'm doing this, but I just can't stand to build the same scope again. I have to do something different. And otherwise it would just be really boring. And if you think about it in history, we've only been building telescopes for a couple, 300 years. There's got to be so many more telescope designs that we have not thought of and not built than what we have built. So why should I even attempt to build the same thing again? So I'm always trying to do something different. And my dad was a carpenter and woodworker and contractor, so I just tended to go with wood. He was very kind and let me use his tools when I was a little kid, and I didn't kill myself. I'm still here. And yeah, so that's where the scopes come from.
Do you experiment with different optical designs too?
I have tried to do that, but the Newtonian, which is a whole nother talk as to why I don't think it should be called the Newtonian, it should be called the Hadleyan telescope, because Isaac Newton, well, anyhow, that's another talk. It is such a wonderful, versatile design, and it is so well optimized to what we're trying to do. Yes, you need something to fix a coma for really fast mirrors, which is a whole interesting half talk alone about Isaac Newton and spherical mirrors and his polishing technique and how he criticized others for their spherical mirrors, but then his was spherical too. But I just not found another design that works quite as well as the simple reflector for me.
David is wondering how many objects you might view in an evening to be sketched later.
Ah, right, 1 to 3. The preparation and mental space I have, I'll go after one main object and then a secondary object, maybe a third one once in a while. And then I'll come back the second night, finish up the first one, do more on the second one. The third night, I'll do the second one more. So I have these series of observing projects that I work on that I have stacked up. And I'll spend quite a bit of time on one project. So, this whole business of star hopping and everything, I don't really go from I don't really go from object to object, so I don't really need to star hopping. Whatever, I just get zeroed in on the same object and I sit there for a couple of hours until I think I get enough of it to go inside and draw a better real drawing.
So on a completely different topic, Howard is wondering if you prefer Miles Davis or Wayne Shorter.
That's really not fair. Yeah, Miles Davis was so inventive. Who was he married to? wife was really good too. Speaking of these stories where we single it down to a single name. So the thing with Miles Davis, so I played trumpet professionally for a number of years. He has a lot of imperfections when he plays, but he makes it part of his art. Now, if I played as bad as he sounded on some of the jazz pieces, I would be fired before the piece was finished. So, you learn how to play really well, and then you learn how to play, should we say, improvisationally, like Miles Davis. So he was such a wonderful talent, just amazing. The thought process in his head, I just can hardly glimpse a picture of it.
So Rob and Gary both remarked that if you kind of shared the rough quality of early drawings, it might inspire other people who are afraid to even start.
It might scare you away. Really, you cannot be worse than me. I mean, gosh, do I have to show you, embarrass myself? Please, no. Here we go. 15 people from the Eugene Club a few years ago never had drawn a sketch in their lives. So I was just amazed. They all had something I thought was unique that they said, and no two were alike. So the way to do it is just to get out there and do it. And you'll get better at it because you'll go, you know what? So that's what I was talking about. You observe and then you sketch, and then the sketching informs what you're going to look at. What you look at then, based on what you think you can sketch, is so you go into this feedback loop and you gradually get better at it. The best thing I can say is just to go try it sometime. And for $4, it's pretty hard to beat. And if you don't like it, just recycle the paper the next day, or just say, the dude got it, sorry about that.
Ed's wondering why you prefer Newtonian design over a catadioptric design.
Because I make my own mirrors, and I can make a mirror. The catadioptric design requires a large lens in front. And remember when I said I had no patience? Man, if you're going to make me make a two-sided lens accurately like that to go along with a mirror too and a diagonal, it's like, so just a single mirror and by the diagonal is good enough for me. But let me say one more, if I could just finish it. What I try to imply is that the scope doesn't matter that much. It really matters what you see through the eyepiece and what you make of it. I know when we look in light polluted skies, it can look pretty washed out, but there's something there to see. If it's too washed out and you can't really see much of Andromeda galaxy, don't try it. Go onto a double star, or go onto a carbon star, or M103, an open cluster in Cassiopeia. These are really beautiful objects. You don't necessarily have to fight a washed out view and say that, that's just terrible. There's stuff out there to be seen in any scope under any conditions. And I just don't think the scope is actually that important.
Jim is wondering if you did any drawing during the 2017 eclipse.
No. And so I've been on 7 eclipses. I managed to see all 7 of them. The problem was that I was all set to go. I had my sketching material there. And I've never seen, and what was it that we had at OSP at minute 20 seconds, 25 seconds? It wasn't very long. So here's how long the eclipse lasted at OSP. 1001, 1002, 1003, 1004, 1005, it's done. It's like it was over with. And I will say the view through my 10-inch Richfield scope was undescribably beautiful. And I looked through it for the first glance and I just thought, there's just no way I'm even going to be able to draw this. It was so stunningly beautiful and so much detail, I just gave up on it. But I had grand plans to try to sketch something.
So Brett's wondering if you think that the integrated flux nebulae would be more obvious in a binocular telescope. And
Yes.
if so, what would you do to maximize the aperture field of view while designing the scope?
Yes. So we had a shootout in my house because, well, I'll just say Jerry Olten, who's an editor of Sky and Telescope, he's always like, well, Mel, your scopes are not that much special. And, he's right. And then Robert Asamandi came. He's been working on this crowd funded 6 and 8 inch vinyl scope and a couple of other really interesting and intelligent club members came. So we had to shoot out with these different scopes. And I had my 25 there and my 10, and the others brought their 10-inch scopes. And it was really amazing. So of the 3 10-inch scopes, my 25-inch and 8-inch binocular, guess which one actually performed the best on IFN and some of these really, dim, broad nebula? It was the 8-inch binoculars. So I would love to make a binocular wide field scope. It's for those of you who have ever thought about it, it is a formidable design decision. You got to align them, then you have to figure out how to get each one collimated. You have to figure out how you're going to get your eyes onto it. I don't know, it's just really, really difficult to do that. So, but the views are incredible. And, we had that case of the stolen telescope in Portland. You might remember that Steve Swayze lost his 12-inch vinyl scope, the dual 12-inch scopes, to a theft too many years ago. I think Steve got his van back, but the scope was never to be seen again. So that was a huge loss. But every year at OSP, people come with vinyl scope. If it's not Robert Osmande, it's a Frank Supansky, or that a wonderful amateur from Japan who came over a few years ago. And the views through these scopes are really inspiring. I just wish, I was up to building one.
So I think we've reached the end of the questions. That you got a lot of really nice comments, and I really hope that you go back and read through the chat at some point.
Okay.
Thank you very much, Mel. It was really nice to hear your perspective and see your really great sketches and to learn about your scopes and everything. I think a lot of people really enjoyed it. You're getting a lot of really nice feedback in the chat.
Well, thanks. I enjoyed putting the presentation together, and I sure appreciate your attention. These Zoom presentations are really fascinating because, people are not captive in the room. So things and distractions are going on. So I appreciate your attention.
Thanks again. Thanks everybody for coming. I hope you all have a very nice evening, and it'll be fun to see you again next month. Take care.